Where am I? Who am I? What am I?
Trey.
That's me. Who is that now?
There was what you need to learn and not enough time to do it.
What?
Come, follow me.
Welcome to the neighborhood.
Yeah, math is still pretty good.
Here the kids do math all day.
Sometimes they even get carried away.
They're learning math. We still need to find something to rhyme with that makes sense with
Learning new things every day.
But never how to get away.
Math. From math. Hey now, it's the cool kids.
Okay, guys, look, what happened? You're supposed to do like the jump thing, and then it's supposed to be an awesome cut. Look, I don't know. I mean, I think we all need to start taking this a little more seriously. We need to start feeling the energy. Okay, my job's on the line. We need to make sure. This episode featuring Trigmaster.
What did you do to him?
I forfeited his life. Isn't that what you wanted, bro?
No! Oh, geez, I better get out of here then. Hey, I think we should try to stay positive right now, guys. We can find Trey if we really try.
He's right. We need to figure out what happened to him. I'm totally here right now, by the way. Let's go.
This is really sudden, but okay.
Where are you?
I'm all around you, yet nowhere at the same time.
Doesn't make any sense.
This place can be unpredictable at times. That's why we must be vigilant. You were sent here by someone, that much I know.
Math guy.
Exactly. You were trapped within a pocket dimension.
Why? Why are you here? Who are you?
That is not important. You want to get out, yes?
Yeah.
As do I. Maybe I will one day. But for now, the way out is locked by a gate. The code must be cracked.
And how do we do that?
Tell me, what do you know about the unit symbol?
So, I mean, where do you think the math man sent him?
Who is that? If you need help finding someone in another block dimension, I can help you.
That's oddly specific.
Yeah, well, I know what I can do.
I mean, maybe, yeah? Well, I mean, maybe we could use your help, friend.
Fantastic. I am Trigmaster, the master of all things related to trigonometry.
What's trigonometry?
Trigonometry is many things, but let's start with the basics.
No, we just got through with math for today.
Alexander has a point, but let's be nice here. Is it relevant to finding Trey?
Of course.
No, then let's do it.
Hey, have you heard of positive and negative angles?
Yeah, what about coterminal angles?
Oh, positive angles, they're like this.
I don't want to do that, but negative angles go the other way.
And the bottom's always fixed on the x-axis, which allows revolutions around the graph.
Oh, who are you?
I'm new.
Yeah, well, did you know that Geico can save you 15% or more on car insurance?
To learn about trig, we're going to need to cover three things: sine, cosine, and tangent.
It's like the 10 Commandments.
Nah, you know what? No, even I can't agree with that.
Let's put these three things in context. Who here knows what a number is? Awesome, friends. You're already farther ahead than you know. Now, let's say you want to find a different part of a number. or in this case, a friend trapped in another pocket dimension.
Por ejemplo, digamos que queríamos a buscar... What?
Let's put it this way, try and find something out of another.
Oh!
Yeah! Hey, now follow me. See, sign is an operation.
Oh yeah, like a game where you stab the guy a bunch of times.
Did we play the same operation?
Yeah, you have the guy and you have the tweezers and you stab him and you fill him with various objects. He comes in a box.
Oh yeah. Yeah.
I'm just gonna say I agree with that, so we can get away from whatever that is.
Now, sign is typically graphed to show a relationship of some kind. It's also cyclic. Let's say you have a pizza cutter and it's really close to your face.
Man, I hate when that happens.
But before we go, we need to talk about
Radians?
Yes. They are the heart of the unit circle.
Are they related to that big cat in Life of Pi?
Close. They're related to pi. Yes. The unit circle has this pocket dimension locked up. The math man put a curse on it that makes it practically impossible to open. However, with my help, I think you can figure it out.
Wait, why can't you leave again?
Ever play the game Operation? Oh, I'm joking. No, I have no physical form. Not anymore. But this is not the game of 100,515 questions. Not today. No, the unit circle lock is just over the way. We must make haste.
Hey guys, today we're doing a cool stunt, yeah, come with me, I love this so much. Here it is, 30, 60, 90 triangle, alright, 2x, x squared root 3, makes up part of the unit circle. 45, 90 triangle, x square root 2. Truly magical. Anyway, that's it, everybody. Tutorial. Tune in next time. Oh, Jesus.
We also have a friend, cosine and tangent. I mentioned that these things can be graphed. Let's start with sine, and let's go back to that analogy that I made earlier.
Oh, the pizza cutter one?
Yeah, I was just talking about radians. So let's go over what they are.
0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6.
These all correspond to the different parts of the unit circle. What's the unit circle? So let's say this is the pizza cutter.
That's the worst pizza cutter I've ever seen.
And that it's separated into different parts, like a pizza itself. Whoa! However, these parts are not random. Each has a different angle measure, determined from the radian. They are
0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees.
That's enough.
They're on the board. The unit circle covers all the information we need for finding angles, coterminal angles, and those three guys we mentioned earlier, sine, cosine, and tangent.
Information?
So, for any question on all of your minds is probably, what exactly is a radian? Well, radians are used to measure angles, but they can also be used for things outside of the unit circle, such as calculus, arc length,
confused and scared.
In fact, the circumference of a circle is actually just one revolution in radians. But let's say we want to find a radian. How do we do that? We'll come right through here, and I'll show you.
You wanted to show me what?
Nothing. I want to tell you how you can go about cracking the code of the unit circle.
How is that?
You need to take your radians. Remember those?
Oh, the pi guys.
In order to find the measurement of a degree, you must divide it by 180.
Why 180?
Because 2 pi is 360 degrees. Therefore, pi is half that, aka 180 degrees. In order to convert, you must flip it. Divide 180 by pi radians.
How did you make floating numbers and stuff?
I didn't.
Oh.
Alright, we are getting closer. Just go through that door over there.
It's pretty big for a pocket dimension.
Tell that to the director.
What?
Nothing. That door over there, just go through it.
Today, we're going into the depths of Mathland to talk to some big players in the math game about why not to use white bag. White bag.
Yo, I'm sine.
I'm cosine.
Will!
And I'm tangent.
Where's your control?
If you grab me, I go like this.
I go like this.
You can't grab me.
Actually, yeah, they can.
We're based on the unit circle, not white bag.
If you want to stay cool, stay away from that stuff.
Don't be a fool. Stay in school.
Don't be like this guy.
Yo, I'm Ice Hammer Run Doggy Dog.
You want to stay mathematical? Stay away from the white bag.
This has been a message from MADISON.
That's how you find a radian of a degree. Now, about sine, cosine, and tangent.
Hey, I know about those now.
Me too.
Yeah,
Nigel.
I actually know about this too. I'm not sure how.
Oh, okay, then that's quite strange. But anyway, so you know that you can graph them to show their relationship based on the cycle of the unit circle? Yeah. Okay, this is awkward. I bet you didn't know about inverse trig. Great, so let's talk about that. See, us cool kids call it advanced trigonometry.
Hey, we're the cool kids.
Hey, he's right.
End this.
See, in order to find the inverse of these three operations, we need to take a look at secant, cosecant, and cotangent. How do we do that? Flip them. Ah!
Why are we outside now?
This is a pocket dimension. Rules don't apply here. Except for gravity, inertia, velocity.
Okay, so anyway, what are we doing?
Let's cross the river of 1,000 sorrows.
Sounds good, let's do it.
Oh, if you flip everything, then you just have 1 over whatever you have?
Exactly. Cosine is x and sine is y. So you flip them. But it's a bit more complicated than that. Since it's inverse, cosecant refers to y instead of x and vice versa. Cotangent is easy. It's just x over y instead of y over x.
Oh, okay, sounds good.
Now, since you apparently know about half of this mysteriously, you should have everything you need.
Are we doing it again exactly?
We need to find an open space so a rift into the pocket dimension.
So, what are there, like, multiple pocket dimensions?
Yeah, I mean, like, how do we know which one he's in?
You see, all pocket dimensions are locked. This one is locked with the unit circle.
Okay, this sounds really risky and implausible, but let's go.
Alright, we'll need to do something in order to open this gate.
That was surprisingly easy and not sorrowful.
It's not even wet, it's really overplayed. Now, you have to find the exact location of the gate.
I thought you knew where it was.
I know how you can find out. You'll need to talk to Fish.
Is that it?
Yes, just over there.
Tell me your ways, small mackerel.
Close enough.
He said it's over there.
Back on the other side?
Yeah.
Oh, son of a...
Thank you for tuning in tonight to our special program. And now for the Unit Circle Interpretive Dance. Thank you once again for tuning in. Please go do something better with your life now.
So for this practice problem, we're going to need to find the cotangent of an angle in degrees. Oh, but first, everyone stand back.
This sounds sketchy.
Sounds kind of like a seance or a ritual or something.
Well, it is kind of a ritual. We're trying to open a pocket dimension. Anyway, the cotangent of an angle in degrees.
There lies the portal. We must go to it.
You mean me?
We.
Okay.
First, you need to multiply your degree measured by pi over 180 and then simplify.
Yes.
Oh, then you need to find the tangent on the unit circle by putting its y coordinate over its x coordinate.
Then you flip them and solve.
Perfect. The portal is open.
That's a JPEG image.
And a portal.
No, it's not.
Now when you enter, you'll be in a bridge void. You should be able to communicate with your friend and get him out.
Well, not to be rude, but what if he's not in there?
Right, that won't happen. Good luck, friends. If you ever need me, I'll be around.
Okay then, let's go!
It's a Jiffy image.
A JPEG. You must use what you've learned from the Unit Circle to crack its code. Both from me and from...
Outside sources.
Do you need a moment to think?
Man.
Horrible, dangerous stuff blows you up. But mixed together in the right way, as only I know how. What do you think it meant?
I'm commonly calling this comedy. I'm gonna need knowledge to audibly teach. Wanna be measuring these. Probably prodigies need. Trigonometry. Geometry. All of these angles are commonly used by the Kenneth to unicircle. Measure it out, running rings like a dribble. Non-verbal on paper. No rehearsal, you're able to generate angles, yeah. Hey, yeah, I got the radians, measure the circles like rhythm circadian. Ladies and gentlemen, circle de una te lagas Canadian. Starting at 0 degrees, the radian 0, the next one is pi over 6. Then you got pi over 4, pi over 3, man, I'm reading this off like a script. At 90 degrees, straight up and down, pi over 2 is your number. 90 degrees like it's Fahrenheit, man, it's so hot, making noise like I'm thunder. I've been using measurements, intelligent and relevant. I'll sell it well, it's hella useful, and a hella truthful, and a hella youthful. Never get old, hella youthful. What? 360 degrees, use it to measure triangles or triangles, angles like I don't know which one it is, but I know that it's accurate. Don't get it tangled. What? Use a unit circle. Use a unit circle. Use a unit circle. Hey, hey, use a unit circle. Hey, use it, yeah. Use a unit circle.
You're all here. Warwick? Nigel? Alexander? Dad? Hello, son. Okay, what just happened?
The gate is open. Go through it now.
Oh, wait, what? Why is it in a different place now? It's weird. You should come with me.
I can't. Maybe one day I'll escape, but... Well.
Oh, hey guys!
Trey?
You was here.
incredibly weird and also kind of cool.
What happened?
I was in some pocket dimension. I don't want to get out now.
Yeah, let's get out of here.
Wait, do you hear that?
Who are you guys? I was about to ask you all the same thing.
These guys are weird. Let's go.
Yeah, let's go.
Fun quadrant region, Steven. Wow, color.
It's good to be back.
Yeah, well, you know, we learned all about trig, man. You missed it.
Wait, I did too.
What a weirdly happy, convenient ending.
I hate it, but at least TREY'S back.
Oh, it feels so good.
All right, Trey, let's finish you for good. I don't allow flat earthers and argument losers. Trey? Trey! Oh, that son of a... He escaped, didn't he? Well, no matter. I'll send my aliens after him. Then he'll see. I'll get that Trey if it's the last thing I do. And I'm not alone. I'll get him. Hey, cool kids?
What?
Cool kids.
No. What?
Me too.